Hello guys, today our topic is the magnetic properties of lanthanides. This is the most important topic for BSc and MSc students. What is the magnetic properties of lanthanides? So here we have the steps. So first of all I will give you explanation, after that I will give notes. So now magnetic properties of lanthanides. In first point is, so in these lanthanides all the lanthanides ions are paramagnetic. As they contain unpaired electrons in the 4f subshell, that means all the lanthanides are paramagnetic. So what is the paramagnetic and what is the diamagnetics? So in this unpaired, so unpaired electrons, we have the unpaired electrons in 4f subshell, that is paramagnetic. In this no unpaired electrons, so unpaired electrons లేకపోతే దాన్ని డయామాగ్నెటిక్ అని అంటాం అన్నమాట. సో ఫస్ట్ పాయింట్ ఈస్ all the lanthanides are Nn plus 3 electrons are paramagnetics. So paramagnetic means unpaired electrons, so that so what is the paramagnetic means unpaired electrons. So next one, next point is, so the ions lanthanum, lutetium, cerium, ytterbium, which have 4f0, and what is the all the lanthanides are paramagnetic except 4 ions are diamagnetic. So 4 lanthanum ions, that means lanthanum plus 3, lutetium plus 3, and cerium plus 4, and ytterbium plus 2. These all are diamagnetic. Why? Because which have 4f0 and 4f14 electrons in electron configuration. సో మీకు క్లారిఫికేషన్ కావాలంటే ఎలక్ట్రాన్ కాన్ఫిగరేషన్ మన నోట్స్ డిస్క్రిప్షన్లో లింక్ ఇచ్చాను, అది చెక్ చేసుకోండి. టోటల్ ఆల్ ద వ్యాలెన్సీ ఎలక్ట్రాన్స్ ఆఫ్ లాంథనైడ్స్ అండ్ యాక్టినైడ్స్ మన ఛానల్లో ఉంది, అండ్ అది ఒకసారి చెక్ చేసుకుంటే మీకు అర్థమవుతుంది. సో ఫస్ట్ పాయింట్ ఈస్ ఆల్ ద లాంథనైడ్స్ ఆర్ పారామాగ్నెటిక్. సో సెకండ్ పాయింట్ ఈస్ some lanthanum ions, that means lanthanum, lutetium, cerium, ytterbium is diamagnetic. So all the lanthanums are paramagnetic except these 4. So that is the second point. And third point is, so third point is the magnetic moment originates from two kinds of motions of the electrons. So ఇక్కడ ద మ్యాగ్నెటిక్ ప్రాపర్టీస్ కైండ్ చేయడానికి మనము 2 మోషన్స్ ఉంటుంది. దట్ మీన్స్ వన్ ఈజ్ స్పిన్ మోషన్ ఆఫ్ ఎలక్ట్రాన్ and second one is orbital motion of electron. So in this, what is spin motion of electrons? Now this is the orbit, so this is the orbit and this is the magnetic moment. This is the direction. So spin means direction, clockwise and anti-clockwise. So this is the direction of spin. So this is the direction of spin. So this is the outside is the electron. Now coming to orbital motion of electron, same as it is, this is the magnetic moment. So in this orbital moment, this is the orbital and this is the electron, and this is atomic nucleus. This is atomic nucleus. All our electron is outside, అంటే ఆర్బిటల్కి బయట ఉంటుంది ఎలక్ట్రాన్. దిస్ ఈజ్ మూవింగ్ లైక్ దిస్. సో కమింగ్ టు స్పిన్ ఆఫ్ ఎలక్ట్రాన్స్, నౌ So spin electrons, coming to spin electrons around its own axis. Coming to orbital motion electrons around the nucleus. So now what I am saying here, third point is the magnetic moment originates from two kinds of motions of the electron, that is one is spin motion of electron and another one is orbital motion of electron. What is spin motion? When you have to take the orbital, direction movement is clockwise and anti-clockwise, spin around its own axis. సో ఆర్బిటల్ లోపలనే ఇది క్లాక్ వైజ్గా యాంటీ వైజ్గా క్లాక్ అండ్ యాంటీ క్లాక్ వైజ్గా ఎలక్ట్రాన్ మూవ్ అవుతుంది. సో కమింగ్ టు ఆర్బిటల్ మోషన్ ఆఫ్ ఎలక్ట్రాన్స్, this is the atomic nucleus. So around the nucleus, so this is the nucleus. When electron is passing through the orbital around the nucleus, so this is the orbital motion of electron. So and coming to fourth point, so coming to fourth point, magnetic properties of lanthanides. So in this observed magnetic moment is present in both the spin and orbital motion. So when you have to calculate the magnetic properties, spin plus orbital motion. So this is the coupling. You have to consider the both the spin and orbital coupling of the equation. You have to write this. So fourth point is spin and orbital. It is considered 4f orbitals deeply buried. Orbital motion will not be quenched. So we have to consider that spin and orbital contribution. That means spin orbit coupling. So that is the fourth point. And next point, fifth point is, so now this can be calculated. So this can be calculated to the expression of what is mu is equal to 4s s plus 1 plus l into l plus 1. This is we have under root. So now we have to calculate the magnetic properties of lanthanides. We have to use 4s into s plus 1 and l plus 1. That means spin and l means orbital motion. So we have to consider both the spin and orbital motion. So in this, s is the resultant spin quantum number, l is the resultant orbital quantum number. And next point is, in lanthanides, spin contribution s and orbital contribution l, these both are coupling together to give a new quantum number, that is z. So in this lanthanides, spin and orbital motion coupling together, it can give a new quantum number j. So Hund's third rule, j is equal to l minus s and j is equal to l plus s. So l minus is when the shell is less than half fill. Coming to l minus n, shell is more than half fill. Okay, so spin and angular momentum, orbital motion, coupling together, it can give new quantum number z. So now we have to calculate the Hund's third rule, j is equal to l minus s less than half fill and j is equal to l minus s l plus s shell more than half fill. So this formula of effective magnetic moment for lanthanides, and next formula is these two are coupling together, it can give mu effective, that is equal to gj square under root j plus 1. So this formula also you have to calculate the magnetic properties of lanthanides. So in this, g is equal to Lander's g factor. So this is the explanation, and I will give the notes to the points wise. So this is the notes I will give you. So magnetic properties of lanthanides, this is the notes for this topic, and this is the most important topic. And subscribe చేసుకోండి, మీకు వీడియోస్ అన్నీ కనిపిస్తూ ఉంటాయి. అండ్ కంటిన్యూషన్, this is the notebooks for semester BSc and MSc students. Thank you guys.